Hi everyone, welcome back to my channel. In this video, we're going to learn Introduction to Matrices with examples, as well as we're going to learn the types of matrices with definitions and examples. So the types of matrices, 100% you're going to get in MCQs type. So it's very important to both CET, NEET or any other competitive examination as well as your board MCQs. So let's learn the definition of matrix first. So a matrix is an arrangement of real numbers in rows, horizontal lines, and columns, vertical lines. So it's arrangement of real numbers. So rows means horizontal lines and columns, you know that it is vertical lines. So let's learn how to represent a matrix. So this is a basic in this chapter to know how to represent a matrix. So A is equal to 8, 5, 10, 11, 12, 13. So these are all the elements. So they can give any elements, okay? And this alphabet also, you can take any alphabet for that matter. So the proper way to represent a matrix is by using a closed square bracket. So you can use curved brackets, but it is compulsory to use a square closed bracket in board exams because it looks neat. So better you can use closed square brackets. So now let us know few examples of matrix. So C is equal to 0, 1 and 2. So we have one row and two columns. One row and two columns. So row is horizontal line, so we have only one horizontal line with two columns. This is how you have to represent. So you have to represent, if they have given 0, 1 and 2, you have to write the number of rows and columns. So this indicates the number of rows and columns. Okay. So next example, A is equal to 0, 4, 0, 3, 24. So how to write this? So there are only one row. First you have to represent row and then column. There are only one row and three columns, 0, 4, 0, 3 and 24. Three columns are there. So B is equal to 1, 2, 3, 4. So 2 rows, 2 columns. 2 rows, right? 1, 2 and 3, 4 is 2. First row and second row. And 1, 3, 2, 4 is first column and second column. 2 into 2. So a matrix is an ordered rectangular array of numbers or functions. So A11, A11, A12, A13. So this 1 means it indicates the number of rows and column. 1 means 1 row and 1 column. 1 row, 2 column. 1 row, 3 column. 2 row, 1 column, like that. So it can have n number of elements in it. So this you have to know for the future problems. So it is important. So you get problems after this. So it is very important for that. Just remember, if they are given like this or if they are given like this, you have to remember that Aij into m into n. Okay. So let's learn the types of matrices and definitions with examples. So first is we have row matrix. So first, before the definition, if I give you example, you get a clear understanding. So let's see the example. 0, 6, 0, 3, 2, 4. So this is, we have one row and three columns. So it's 1 into 3. So I'll give you one more example. A, E, I, O, U. So this is 1 into 5. And the third example is 100. So this is 1 into 1. So here we can easily identify that we have only one row, but we have so many columns. So in the definition, in the type only, we can understand that row matrix is a matrix having only one row. So see here, only one row, 1, 1, 1, and you can have many number of columns, but it has to have only one row. Okay, this is called as row matrix. So let's go to the second type, that is column matrix. So what do you mean by column matrix? So first I'll give you examples. We have 1, 4, 3. So this is only one column. Sorry, we have 3 rows and only, it is, so row is horizontal line, right? Okay, so column matrix means it must have only one column, but it has 3 rows. 1, 4, 3 is the number of rows. So column means 1, 4, 3. So it has only one column with 3 rows. So what should you write here? So 3 into 1. 3 rows into 1 column. So I'll give you a second example. So x, y. So 2 into 1. So we have 2 rows. X is a row, y is a row, but column is x and y only. Means there is only one column. So 2 into 1. And I'll give you a third example. So this is 1 into 1. That is mean row is also 1 and column is also 1. So how can we define column matrix now? So it has matrix having only one column. So matrix having only one column is column matrix. Row matrix is matrix having only one row. Okay, let's move on to the third matrix. So the third type is zero matrix, null or null matrix. So it has many names. So zero matrix, null matrix, empty matrix or void matrix. So in the MCQs they can give any of these names, so better not to confuse. So just read properly. Zero matrix, null matrix, empty matrix is all are the same. So from this name only we'll get to know how the matrix is. So I'll give you an example. So 0 is equal to 0, 0, 0, 0, 0, 0, 0, 0, 0. So we have 3 rows and 3 columns, so 3 into 3. So how to define this? So a matrix which has all elements 0 means it contains the elements of this matrix are 0. The all elements of this matrix are 0. That's all. So a matrix in which all elements are 0. That's all. So 0, null, empty or void. So it contains all the elements. See here 0, 0, 0. So all elements are 0. So let's move on to the fourth matrix. So scalar matrix. So first I'll give you definition so that you can understand. So matrix with same number of rows and columns. So a matrix with same number of rows and columns, we call it as scalar matrix. I'll give you an example. So A is equal to 1, 2, 3, 4. So here the order is 2 into 2 and B is equal to 1 0 minus 3 2 4 6 5 0 1. So here 3 into 3. So here you can see same number of rows, same number of columns, 2 rows, 2 columns, 3 rows, 3 columns. So 3 into 3, 2 into 2. So these kind of matrix we call it as scalar matrix. So there is one more important here. Just look carefully. So we call these elements. So 1 4 1. This is called as principal diagonal. So if they ask here, is 2 and 3 principal diagonal, because it is in a cross way, so they can ask 2 and 3 are principal diagonal. They can give you a question like that. But no, this is not principal diagonal. Only when the diagonal from left to right, starting should be left and ending should be right. And here we have the starting from the right, so this is not the principal diagonal, this is the principal diagonal. So the crossed elements are called as principal diagonal, in which the first element of the principal diagonal should be from left only. Okay, based on this you may get questions. And I'll teach you one more important thing here. So trace, they can ask you trace of matrix. So they can ask you in this question, explain the trace of matrix, or like that type of question. So trace of matrix means you have to add all of the principal diagonal. So that is 1 plus 4 plus 1. So it is 6. So the trace of matrix is 6. So they can give a matrix like this, and in option they can give 1, 6, 7, 8. So what is the option? 6 is the correct option. So you just have to add the principal diagonal. So I'll give you a homework that you have to find the principal diagonal for A and the trace of matrix of A. You can answer in the comment section, okay? So there is a small correction. So this is not called as scalar matrix. I'm very sorry. This is called as square matrix. Please correct it. So this is called as square. So imagine that square has equal number of sides. So all sides are equal, right? So remember that the rows and columns are equal. So remember that. So matrix with same number of rows and columns, because all the sides are equal in square. So that is called a square matrix. I'm very sorry. It's not scalar matrix. Okay. It is square matrix. Okay. So the fifth matrix is diagonal matrix. So the diagonal matrix, I'll teach you how. So first I'll give you some example. So A is equal to 1 0 0 4. B is equal to 1 0 0 0 4 1 0 and 0 0 7. So the order is 2, 2, 3, 3. So here diagonal matrix is, I told you the topic diagonal is from, it should start from left and it should end in the right. So here, can you identify the diagonal matrix? So you can observe So this is called as diagonal matrix. So you can observe the only diagonal elements are non-zero, that is 1 and 4, 1, 4, 7. But all the elements are 0 except diagonal matrix. So this kind of matrix is called diagonal matrix. Did you get my point? So instead, the only diagonal matrix, see, these are the diagonal matrix. So only diagonal matrix are non-zero, that is 1, 4, 7. But other elements are 0. Only diagonal elements are non-zero. Here also only diagonal elements are non-zero. So these type of diagonal matrix we call it as, diagonal matrix, of course. Okay. So I wanted to tell something important. So if you are preparing a second PU examination from 2024 to 2025, so there is my Telegram channel where I have given important notes, important MCQs, all types of important PDFs in that Telegram channel. So you can join that channel, so that will help you so much. Okay, that link I'll be giving in the description box as well as in the comment section. You can join. Okay, so let's go to the sixth matrix. So before going to the sixth matrix, I want to ask very simple question. So question I want to ask. So A is equal to 0, 0, 1, 0, 2, 0, 3, 0, 0. So this is the order is 3 into 3. So can you tell me this is diagonal matrix or not? So how I told you, you should identify the diagonal matrix. So here you have 0, 0, 0. Okay, I'll just mark the diagonal matrix. So can you tell, so here also we have 0, 0, 0 all the elements, but diagonal matrix we have non-zero. Here also diagonal matrix we have non-zero and other elements are 0. Can you tell me, is it diagonal matrix? Of course no. It is not diagonal matrix. Maybe other elements are 0, but what I told you, diagonal matrix should start from left. So here diagonal matrix is from right. So it is not a diagonal matrix. Though it has 0, it is not. Okay. So let us go to the sixth matrix, that is scalar matrix. So scalar matrix is, I'll give you definition first, elements, diagonal elements. So diagonal elements are same. So what do you mean by diagonal elements are same? I'll give you an example. So A is equal to 1, 0, 0, 1 and B is equal to 7, 0, 0, 0, 7, 0, 0, 0, 7. This is 2 into 2, this is 3 into 3. So they've asked, the definition is diagonal elements are same. See, you can see the diagonal elements. It's 7, 7, 7. It is 1 and 1. Other elements are 0. But what we learned in diagonal matrix, in diagonal matrix, it is non-zero. See, 1, 4, 7. There are different numbers. But in scalar matrix, we have same numbers. 1, 1, 1. If it is 4, 4, 4, 4. If it is 7, 7, 7, 7. See, here 7, 7, 7. 1, 1. So any number for that matter, if I take the number as 9, it should be 9, 9, 9 and the other element should be non-zero. So this is the scalar matrix. So the diagonal elements should be the same number throughout. Okay. So this is called as scalar matrix. So let's move on to the seventh matrix. So the name of this matrix is identity matrix. So this matrix is very important, or it can be called as unit matrix. So unit means one, right? Unity means one, unit means one. So in the definition, in the name of it, only name, you can identify the type of what are the elements. Okay, so the definition is, it is a scalar matrix. So what is scalar matrix? So diagonal elements should be the same number of, it should have same number of diagonal elements. So this is a scalar matrix, it seems. Scalar matrix in which diagonal elements is equal to 1. So here it could be 7, 777 or 999 or 888, but here it should be 1 only. So example, so A is equal to 100 010 001 3 into 3. So here it should be 1 only. It's compulsory that you have to have 1, or it will be a scalar matrix or diagonal matrix if it contains the different numbers. So identity or unit means 1. So it must have 1 1 1 as diagonal elements. So I'll give you one more example. So B is equal to 1001. So 2 into 2. So here 1 1 we have, yes, of course it is a identity matrix. It must contain the diagonal elements should be equal to 1. So I'll give you a question here. So C is equal to 500 010 001. So we have here. So can you guess it is a identity matrix or not? Of course it is not. You can tell here 1 1 2, at least 2 ones are there. No, it is identity matrix. No, it is a, before we learnt now what is a diagonal matrix. There are all different numbers. Say 5 is different, maybe 2 and 1 and 1 is same, but it comes under diagonal matrix. So it is not even a scalar matrix, because if instead of this, if 1 is there, it would be identity matrix, because 1 1 1. Instead of these two, 5 5 would be there, then it becomes scalar matrix. So these type of questions in MCQ is much important. So if you practice thoroughly, you can score well in MCQs. So if you still don't understand or you need some more explanation, so if you can't see the video from first, I'll be giving this PDF in the description box. So you can go through the PDF and you may understand for some extent, till some extent. Okay. So let's go to the next type of matrix. So this is called as upper. So this is very interesting. Upper triangular matrix. So upper triangle matrix. So first I'll give an example for better understanding. So A is equal to, so 1 3 7 0 2 4 5 0 0. So 3 into 3. So this, so what do you mean by triangle? So here only we have the given that it is a triangular, that two upper triangular. So how to identify? So see here, means upper triangle means the, okay, we'll write the definition for better understanding. So it is a square matrix. Square matrix means all the sides, I mean the rows as well as the column should be equal. So the square matrix in which all the elements below the principal diagonal must be 0. So did you understand? So this is the diagonal matrix. So upper means you have to draw a triangle in the up, and down it should have 0. So below elements must have 0. So in the up you'll be having a triangle kind of thing. So it should be in that it should have non-zero elements. Okay, so this is called as upper triangular matrix. So next we have 9th one, we have lower triangular matrix. So see here, next one is lower triangle matrix. So the same opposite thing. So here below you'll be having zeros, and in the up, as it suggests, up means you'll be having a triangle. So here we have triangle in the lower part. So that is lower means, see here we can form a triangle, right? In the up we have zeros. So this is called as lower triangle matrix. So what is the definition for lower triangle matrix? It is a square matrix. This is also a square matrix in which all the elements above the principal diagonal must be 0. See, that's all. And the last type of matrix is equal matrix. So first I'll give you an example. So A is equal to 1 0 3 4. So this is 2 into 2, and B is equal to 1 cube 0 by 10. So 6 by 2 root 16. So 2 into 2. So here you can identify. So 1, you have to compare. So equal matrices means you have to compare A and B. So first let's see the A element. So 1 is 1 and 1 cube the same? Yes, 1 cube is nothing but 1 into 1 into 1. That is 1 only. So 1 cube, yes, we got. So yes, 1 and 1 satisfies. 0, and we have 0 by 10 here. Is 0 by 10 is 0? Yes, of course. Anything divided or multiplied by 0 is 0. So 0, 0, it's equal. So 0 by 10 is nothing but 0, so it is equal. So 3 and 6 by 2. 6 by 2 is nothing but 3 only. So 3 and 3, yes, it is equal. So 4, here we have root 16. Root 16 is nothing but 4. Again 4 and 4. See, like this they don't give you exactly 1 1 0 0 3 3 4 4. They give you little twisted pairs, and you have to compare A and B. Okay, so that's all. So if you want to write the definition of this, I'll tell it orally. So two matrices A and B are said to be equal only if their orders are same and the corresponding elements are same. The orders must be same. See, the orders mean 2 into 2, 2 into 2. This is the order. So 2 into 2 is same. So if there is 2 into 3 and 1 into 2, of course it's not equal matrices, because first you have to check the order and then you have to check the corresponding elements, 1 cube, like that. Okay. So thank you. So these are all the basics, an introduction to matrices and types of matrices with examples and definitions I have explained in this video. So any doubts, you can comment in this video, and the notes of this video will be given in the description box. You can refer it, as well as you can join my Telegram channel for preparations of 2nd PUC examination 2024 to 2025. Thank you.